Hey guys, welcome to the level 2 algebra exam paper from 2017 worked answers. So in this video what's going to happen is I'll go through each question, write down the answers and let you know what you need to do for achieve merit and excellence. What I'd also ask you guys to do is that for each question, pause the video at the start of the question and then try the question out by yourself just to see how far you can actually go with the answers. Alright, and I'll also try and incorporate calculator use whenever I can. But let's get started. So, the first question is this one here. It's been asked you simplify the following and leaving the answer in positive indices. So, anytime I see a negative power, I need to actually convert it to a positive power. So, my first step in this case is going to be 3. But because 4x is the only thing that has negative 2 to it, 4x squared will be in the denominator now. Now just this part is not going to be enough. You need to expand the denominator. So when you do that, you're going to end up with 3. 4 squared is 16. And then x squared, that's just going to be x squared as is. So a nice easy question to start the paper with. And this gets you an achieved. Alright, so next question is this one here. Once again, we've been asked to, I think we've got to go back to the previous question. It's been asked to leave the answer with positive indices. Okay, so when you have lots of elements inside a bracket, remember the first thing that I'll always tell people to remember is that 16 here has got a power of 1. All right, that's the first step. So the next step is writing down each of these things with those respective powers. So for example, you're going to get 16 to the power of 1 times 3 over 2, x to the power of 4 times 3 over 2, and that whole thing is divided by x to the power of 6 times 3 over 2. Now, there's more than one way of how to do this particular problem, guys. So I'm not going to cover all the methods. I'm just going to show you guys one of the methods here. Now you got 16 to the power of 3 over 2. So the best thing to do is put this in the calculator. So you've got menu run 16 to the power of 3 over 2. Now one tip that I'm going to give you guys, one of the many tips I'm going to give you guys is this. Whenever you put power in the calculator to the power of something, always put the powers inside of brackets. Okay, so this is going to be 3 over 2. So this is what the answer should actually look like. Because a lot of you guys, when you don't put the power, what happens is you might actually end up getting the wrong answer. Okay, that's the difference between putting the powers or no powers. So anyway, we got 16 to the power of 3 over 2, which equals to 64. Multiplied by 4 times 3 over 2, that's going to be 12 divided by 2, which is... Where did we go? Sorry about that. 4 times 3 over 12, that's x to the power of 6. Divided by 18 divided by 2 is x to the power of 9. Okay, and now we need to simplify the x to the power of 6 and x to the power of 9. So because there's 3 of them in the denominator, this is going to end up looking like x to the power of 3 in the denominator. Because that cancels out with this, and you're left with just with 3. So this question here is actually a merit question. So do it all the way to the end. You actually get a merit. Correct power of x or number. So if you get one of these things, either the numerator correct or the denominator correct, you could get an achieve for it. Okay, so let's go to the next question. Right, we got fully simplify this expression questions, all right? Now, the way I tend to do these questions is that I know that these questions, they're going to have two factors, two common factors, and then you got to factorize, and then you got to find two common factors and then cancel them out. Now, if you're comfortable with factorizing, for all, just go ahead and just work through it. But I'm going to show you a couple of tricks here as well. Now, the first trick is this. You should be able to simplify either numerator or denominator before you even actually factorize it. Sorry, I shouldn't have said simplify. It should be a common factor. So when I look at 2x squared minus 50, I can see that 2 is a common factor. So I can rewrite this as 2x squared minus 25 divided by, and then with the bottom one, I've got 3 as a common factor, so I'm going to take 3 out, and I've got 3x squared minus 13x minus 10. So with this next step, what I could do is, because 2x squared minus 25, I can write that as x minus 5 and x plus 5. And that's divided by 3 times 3x squared minus, I've got to factorize this. I mean, I'm going to do that separately here, folks, on the side here. So I've got 3x squared minus 13x minus 10. So doing this the long fashion, the old and the long fashion way, if you'd like to call it. So I've got 3 times, my arrow has gone a bit too far. 3 times negative 10, that's negative 30. So I'm looking for two numbers that multiply to negative 30 and add up to minus 13. So my two numbers are going to be negative 15. Let me just put that in a different color there. So negative 15 and positive 2. So then what I can say is I've got 3x squared minus 15x plus 2x minus 10. And at this point, I want to do partial, I want to split them up and factorize the two terms on the left-hand side and the right-hand side. So on the left-hand side, I've got 3x as a common factor, which means it'll be x minus 5. And then on the right-hand side, I've got 2 as a common factor. So it'll look like this. And of course, x minus 5 and x minus 5 is a common, x minus 5 is a common factor. And I've got 3x, of course, don't forget that plus there, plus 2. So then what we have is we've got a x minus 5 and 3x plus 2. And at this point, we can cancel out the two x minus 5s. And our final answer ends up being 2x plus 5 divided by 3x plus 2. Okay, now grades wise, correctly simplified is a merit. Now it says either numerator or denominator correctly factorized. So it could be this, could be this. One of them could get you an achieved. Now I want to actually show you guys another little cheap trick here. So this is when you have this quadratic here, right? And you want to get to this stage real quickly. I kind of use this method in a, it works, but it also is, it's a, how do I say, it's a, you got to understand a bit of what's happening as well. Sorry, my computer just froze there, but I think we're back. So the way it works is this. What is my equation? Let me actually go here. So remember my equation is 3x squared minus 13x minus 10, right? So what I can do is, I don't have to go through this whole process on the left-hand side. I can go to the calculator and put it in solver, not solver, polynomial solver. So go to polynomial, degree is 2, and I put these values. I've got 3 minus 13 minus 10. Okay, and when I do this, I've got two solutions here. So I've got x is equal to 5, but the next thing I want to have a look at is particularly this part here. I don't want to look at the negative 0.666. I want to look at the fraction version of it. So what then I have is I've got two solutions, all right? My two solutions are that x is equal to 5 and x is equal to negative 2 over 3, all right? Now what I'm going to do is from here, I'm going to reconstruct my factors. Because remember, if this is the solution, then I just need to rearrange it. So this would become x minus 5 equals to 0, and this would become 3x equals minus 2, and then 3x plus 2 equals to 0. So what I'm doing is I'm going back, like almost I'm going backwards to here, and what you should see is that we've actually got our two factors right there. And a good way to check that these are our two factors is by just doing the first term and the last term. So if I do 3x multiplied by x, I get 3x squared. And if I do plus 2 multiplied by minus 5, I get minus 10. So that's how I know that these two factors are correct. So guys, you can actually use this method, like if you're finding that you're getting stuck in this long-winded way on the left-hand side, particularly this one here. You can actually use the calculator shortcut to get the solutions and then work backwards to get your factors as well. Cool. That's it for this question. We go to the next one. Okay, so what we have in this particular question is we've got a square photo. We've been given the border around the photo is constant width. So the border is this gray shaded area right here. All right, and that's got a constant width. Now it says the photo has side length n minus 2, card has 2n plus 6. If the total area of the border is 200, find the width of the border. So what we have is this gray area right here. The gray area equals to 200. And we literally have two squares. All right. So I don't know why I'm drawing a square when there's already a square there. Sorry, guys. So we've got our first square here, which is 2n plus 6 and 2n plus 6. And then our second square is n minus 2 and n minus 2. So if we take the first big square, which is this one right here, I'm going to call this the blue square, and I'm going to call this the black square. So if I go the blue square, and I subtract the little black square, I end up with an area of 200. So the blue square is going to be 2n plus, so let me just set up the formula first. I've got 2n plus 6 squared minus n minus 2 squared, and that's all equal to 200. Okay? Now it says set up a quadratic or finds expression for widths in term of n. No, it's all right. I'll just work through this question. So let me just write this up here because I need a bit more space to work with. So we've got 2n plus 6 times 2n plus 6 minus n minus 2 and n minus 2 equals 200. So expand the brackets. We've got 4n squared plus 12n plus another 12n is 24n plus 36 minus, now this entire thing I'm going to put in a bracket, so it's going to be n squared minus 4n plus 4, and that's equal to 200. So simplifying this, I got 4n squared plus 24n plus 36 minus n squared plus 4n minus 4 equals 200. So like terms, got 4n squared and n squared, which is 3n squared. 24 and 4 makes 28. 36 and negative 4 is plus 32. And of course, I'm going to bring this 200 back to the left-hand side to make the right-hand side equal to 0. So what I have is I've got a nice quadratic that looks like this, which is 3n squared plus 28n minus 168. Okay, so at this point, I need to solve for n. Now, I'm not going to waste my time with trying to factorize this, guys. I'm just going to go straight into the calculator and put in 3, 28, negative 168. And my two solutions are 4.15 and minus 13.49. So I figured out what n is, but I don't think that's what the question's asking for, because the question's actually asking for find the width of the border. All right, now if I want to find the width of the border, you could do it in two ways. You could actually work out what the base for the blue square is. So if you were to do that, so I've got the blue square, which is 2n plus 6. Now remember that this negative value we can't really use because that's going to give us a negative measurement. So I'm not going to worry about that. I'm only going to worry about the 4.15. So if I do that, I get 2 times 4.15 plus 6 as the base of the blue square. As for the base of the black square, it's actually n minus 2, so it's going to be 4.15 minus 2. Okay, so with the black one I've got it as 2.15. The next one I'm going to get is 8.3 plus 6 is 14. Oh, hang on. 14.3. So now the question is asking for the width of the border. Now remember, the width of the border is just one part of it. All right, now if I go the base of the blue triangle minus the black triangle, the two yellow bits, it's actually twice the width. So that means the width is going to be 14.3 minus 2.15, and then it's got to be divided by 2. Because remember, there's actually two widths in that. You can see in the diagram with the two yellow parts. So I've got 14.3 minus 2.15, and that divided by 2 is roughly 6.075. Okay, now of course guys, with this answer it might be a different one in the answer schedule, because you know, rounding error is always got to keep an eye on it. So final correct answer gets you an excellence. Both solutions of quadratic found is a merit, so that's up here. Sets up a quadratic. I would actually say if you're setting up a quadratic, you're looking at an achieved here. I don't know, unless they're talking about this part here for an achieved, but yeah, I'm not really sure guys. I wouldn't know which one it is that they're qualifying there for achieved. But anyway, that is it for this particular question. Let's go to the next one. Okay, so this question here is like, what we have is we've got one of these average questions, pops up every now and then. So what we have is teacher has hired a school bus for $560, right? The cost is shared equally between the students. So we can say the first part that we can actually say is that you've got 560 over something, right? That's what the average price is going to be. Or we can say 560 divided by number of students. There we go. So that'll actually give you the price of the tickets. But now they're saying at the last moment, 3 of the students were unable to go. Now because 3 students were not able to go, the price actually increased to $1.50. So think about it like this, all right? So let's say if you have 560, let's say we've got 10 students going. Just for an example, if 10 students are going, then your ticket price is going to be 560 divided by 10, so it's like $56 each, right? And then on the other hand, if you have only 7 people going, then your average price is now gone up. It's gone up to $80. And then you're saying that means how much has the price increased by? The price has increased here by $24. So what we're doing is we're doing this one minus this one here. I hope that kind of makes sense. So what I should have done is like 80 minus 56 is equal to 24. So the reason why I'm trying to show this is because and then, sorry, hang on, let me just show you one more step. 560 divided by 7, and then here it'll be 560 divided by 10 equals 24. So what I'm trying to show you guys is that 24 is that $1.50, all right? Because 24 is how much the price was increased by for in this case. That means that for the original one, we don't know how many students are going, it's $1.50. And as for the price, it's going to be 560. You can do it 2 ways. You can actually write this as X as the original students that plan to go. So you can actually write it as, or you could say x as what the current people are doing. So you could actually have this as x plus 3 like this, and x, or you could also have 560 over x minus 3 minus 560 over x is equal to $1.50. All right. I know I kind of played around with that, but it's just, sometimes it's easy to actually just take a few numbers and just play with those numbers to try and understand what the question's actually asking you and then work around it. Okay, so now that I've actually set up this equation, I can start working it out. So I've got 560 over x minus 560 over x plus 3 equals 1.5. So what I need to do is cross multiply, but before I do that, actually no, cross multiply is the way to go, sorry. I'm going to cross multiply this, and I've got, basically I'm going to do this. But rather than cross multiplication, I'm going to show you guys the long-winded way of doing it, but it's still the same kind of concept. So I'm going to multiply the numerator by x plus 3 and the denominator by x plus 3 minus 560 over x plus 3 multiplied the numerator by x and the denominator by x, and all of this is equal to 1.5. So I've got 560 x plus 3 minus 560x, and the whole thing is divided by x times x plus 3, and that's equal to 1.5. Now I can move, expand the numerator at the top here, so it's going to be 560x, and then 560 times 3, which is 1680, minus 560x, and then in the denominator I'm going to expand the brackets, which is going to be x squared plus 3x, and all of this is equal to 1.5. So once again, cross multiply, get rid of the x squared plus 3x, but 560x and 560x disappear, so I've got 1680 equals 1.5 times x squared plus 3x, and then 1680 equals 1.5x squared plus 4.5x, and then 0 is equal to 1.5x squared plus 4.5x minus 1680. So at this point I can factorize this using my graphics calculator. So menu and into equation, polynomial, unknown 2, so I've got 1.5, 4.5 minus 1680. So my two answers are 32 and negative 35. And of course I can't really have negative 35 people going on this trip, so the answer is going to be 32 people on this trip. And that right there gets you an excellence, guys. Quadratic equation formed gets you a merit. And as for achieved, that's this part right here. I think the most challenging part of this question is the initial setup of the question. But once you set up the question, it kind of just flows quite nicely. Okay, let's go to question number 2. So question 2 here, we've got just a log equation here. So solve the equation for x. So we know that this can be written as 2 to the power of 10 equals 2x. Put that in the calculator, guys. 2 to the power of 10, 1024. So x equals to 1024. All right. Again, another nice, easy, achieved question right there to start the question. Now we go to question B. It says log x 49 equals 2. But I guess the most important thing to notice is this extra part here that says justify your answer. So when we have log x 49 equals 2, we know that we can rewrite this as x squared is equal to 49. And when we take square root of 49, we get x is equal to plus 7 or minus 7. But remember that a base, I'm talking about a base right there. Base actually can't be negative, so you need to actually mention that as a statement. Base can't be negative, therefore x is equal to positive 7. This statement is going to get you a merit. Writing it in index form gets you an achieved. Okay, it's one of the more easier merit questions to get from last year's paper. All right, question number C. It says find the value of this particular thing. I'm going to give you guys a little tip here. Whenever you have, let's say like something like this, and you want to solve this, what you normally do is you'd actually put this as x, and then you go 3 to the power of x is equal to 9, and then you go, oh yep, you kind of work it out with logs and you get x is equal to 2. But here's the thing, when you get a question like this, you can put this directly in the calculator, because all you have to do is this. When you have log with 3, 9 like that, you basically just go log of 9 divided by log of 3. When you do that, you get 2. So if you were to do that other question that's been in the paper, you can actually check your answers if you want to. But what you could do is you could actually go log of 1 over 125 divided by log of square root of 5. So the answer is actually -6. But this is, and the thing is, you could actually just go, you could directly put -6. But I'm just looking at the exam schedule here. The schedule actually says problem solved is a merit, written in index form is an achieved. So yeah, I'm not sure, guys. I mean, even if you get the answer as -6, I think you got to show some sort of working. So anyway, let's show the working. So what we're going to do is we're going to put this as x. All right. So then what we can do is square root of 5 to the power of x equals 1 over 125. Now, if you want to, do any sort of excellence exponential questions, this is a good question to watch, just in terms of understanding how to rearrange powers. So the first step I'm going to do is square root of 5 I can write as 5 to the power of half, and that's the power of x. And as for 125, I can write that as 1 over 5 to the power of 3. So then I've got 5 to the power of half x equals 5 to the power of -3. And remember this from last year. If the two bases are the same, then the powers must be equal to each other. So you got half x equals -3. Which means x is equal to -3 times 2, x is equal to -6. And of course, we know we're right because when we did that in the calculator, we got a -6 as well. So it says that writing an index form gets you an achieved. I'd probably say somewhere around there. And the final answer gets you a merit. Guys, I wouldn't risk just writing answers in these exam papers. Just some sort of working or some sort of steps is always going to be beneficial for you. All right, next question. This is one of my favorite questions because I've seen it pretty much come every year since 2012, and I do hope that this comes this year as well in 2018, but never know, man, never know. So what's happening with this question? We've got a computer that actually depreciates. That means it's reducing its value from 4,699 to 1,500 over a period of 4.25 years. Okay. So what we're asked to do is we are asked to actually find the value of this computer after 6 years. The first step we need to find out is, let's actually write down what we have in terms of y equals ART. Now A is the initial value. So in this case it was 4,699. Y is 1,500 because that's the value it's actually depreciated to after a certain period of time, which is 4.25. Now this entire information is actually from the first line right there. So the first thing that we need to figure out is the value of R. At what rate is it actually reducing? So I'm going to substitute all of these things into an equation. So I've got 1,500 equals 4,699 multiplied by R to the power of 4.25. So the next step would be is I get 1,500 divided by 4,699 equals R to the power of 4.25. So we got 1,500 divided by 4,699. So that gives me a rate of 0.3192, which is r to the power of 4.25. And if I want to figure out what r is, all I have to do is the opposite power, not opposite power, that I raise it to the power of 1 divided by 4.25. And by doing this, this is actually going to give me what the r value is. So I'm just going to go answer to the power of 1 divided by 4.25. So when I do this, r is actually 0.764. Alright, now once I've figured out what r is, I can actually go and work out the value of the computer after 6 years. So at 6 years, the time is equal to 6. Y is what I'm trying to figure out. The A value is still 4,699. So then the equation is going to look like this. 4,699 multiplied by R, which is 0.764, and T, which is 6. So I've got 4,699 multiplied by R, which I have already got here, to the power of 6. Okay, and so I get $937.32. And that's basically it for this question, guys. So grades wise, final grade is excellence if you get the final value. Finding the R value gets you a merit. Sets up equation with correct value for A. I would actually say for A, oh, just this part right here. Wow. So just setting up an equation with correct value of A gets you an achieved. It's one of those really strange questions because, yeah, quite easy to get an excellence in this question. Okay, so that's question D. Let's go to question E. All right, so with this question, we've been asked to make P the subject of the formula. Now, one thing I'll ask you guys always to notice with certain numbers, always look for patterns, all right? The reason I say that is because when you figure out patterns, things can just become a lot more easier and you don't have to use complex logs. Because, you could actually use a log equation in this log steps for this particular rearranging. But let's think about this. We know that 81 is actually could be written as 3 to the power of something, and 243 could be written as 3 to the power of something. Okay, so we know that 3 to the power of 4 is 81 and 3 to the power of 5 is 243. So that's literally what I'm going to do there. I'm going to convert this to 3, 4, and 3 to the power of 5. Because what's going to happen is this. 3 to the power of 4, that's 81 there, and that's to the power of px over q minus 3, and that's equal to 3 to the power of 5. Now, because I have the two powers there, I can multiply the two powers, and what I'm going to end up with is 3 to the power of 4 times px over q minus 3 equals 3 to the power of 5. And from here, I can now see that because the base 3 is on the left-hand side and there's a base 3 on the right-hand side, these two powers, that's in the yellow shaded region, must equal each other. So I've got 4 times px over q minus 3 equals 5. And I think once you get here, it's just rearranging to have p by itself. So you've got px over q minus 3 is equal to 5 over 4. And then px over q equals 5 over 4 plus 3. Px over q equals 5 over 4 plus 3 could be written as 17 over 4. And then cross multiply. So you got q times 17, which is 17q, and then x times 4, which is 4x. And that's one way of doing this. You could use logs if you want to, guys. I've seen the answer schedule actually goes through with logs. It's fine. Either way is correct because this one gets you an excellence as well. In terms of converting equation to exponent form, so probably somewhere here, I would say here more like it to get an achieved. Yeah, merit could be anywhere in between this because I've actually done this in a slightly different way compared to the exam script. So yeah, that's what you need to do for this particular question. All right, so next up we go to question 3. Okay, so question 3a. Now you might remember this. I did this in back in question 1b. I showed you guys how when you have two solutions you can actually work backwards to get the factors. So that's basically what I'm going to do here. All right, so what I'm going to do is, because I've got x is equal to -½ and x is equal to 5/2, I'm going to rearrange it. I'm going to get this as 2x is equal to -1, 2x plus 1 equals to 0. And as for this side, I'm going to get 2x equals to 5, 2x minus 5 equals to 0. From here, I have my two factors, 2x plus 1 and 2x minus 5. I expand the brackets, so I get 4x squared minus 10x plus 2x minus 10. Simplifying this, I get 4x squared minus 8x minus 10. And from here, you can see that the value of b, which is there, oh, I just realized what I made a mistake. Sorry, that's not minus 10, that's minus 5. So from here, I can see that b is equal to minus 8. All right, this question here, guys, achieved. Okay, next question. What we've been asked is, for what values of m does this have two equal roots? So the first step I want to do is I want to rearrange this quadratic so that I get 6x squared minus mx plus 3 equals to 0. Now the next thing is this. If there's two equal roots, remember there's 3 situations when it comes to discriminants. No solution, one solution, 2 unique solutions. Now in this case we're looking for 2 equal roots. That means we are looking at this situation here. And remember, for this situation, b squared minus 4ac equals to 0. So I'm going to write that down here. b squared minus 4ac equals to 0, because that's what it means by one root or 2 equal roots. So next step is to write down all my a, b, and c. a is equal to 6, b equals minus m, and c equals to positive 3. Substituting into my equation, I've got negative m squared minus 4 times a, which is 6, times c, which is 3, and that's equal to 0. So I've got negative m squared, which is going to be positive m squared, and then I've got 24 times 3, which is 72. So m squared is equal to 72. M is equal to plus or minus square root of 72. So in this case, m is equal to plus or minus 8.485. Grades wise, this gets you a merit, correct substitution into discriminant, and set to 0. So that means we're looking at this part here for an achieved. Okay, just writing the discriminant formula is not going to be enough, guys. In this case, you actually have to write the equation and substitute the values as well. Okay, let's go to the next question. Now, with this question, it says, find the values for k for which this expression is always greater than 0. If you look at the graph, this is a quadratic. And if it's greater than 0, that means it's not going to have any roots. So it's going to have no real roots, which means our discriminant is actually going to be less than 0. Okay, that's the first step that you guys need to know. Once we do that, then we start extracting the ABCs. So in this case, A is equal to K, B equals minus 12, C equals 5K. And what we have is we've got B squared minus 4AC is less than 0. Substitute the values. So you got negative 12 squared minus 4 times k, because that's what the value of a is, multiplied by c, which is 5k. All of this has to be less than 0. So we got 144 minus 4 times 5 is 20k squared. It's less than 0. Rearranging this, we are going to get negative 20 squared is less than negative 144. And then k squared is negative 144 divided by negative 20. And because it's being divided by a negative number, we need to switch the symbols. And we're going to get k squared has to be greater than 144 over 20. Now, at this point, remember, like this is where people actually end up getting confused. But like if you just look at this part here, k squared is a parabola, and it's a normal parabola. It's going to look like this. And what we want to know is at what point is this graph going to be bigger than 144 over 20. Now I'm just going to do 144 over 20, which is 7.2, right? So I want to figure out when is k squared greater than 7.2. So that right there is 7.2. And I can straight away see that there's actually two zones that it's greater than 7.2. One is there, and one is before that point. So I need to figure out what the x value for that is. And to do that, because y is 7.2, and I know k squared, let me just show this slightly here. So I've got k squared equals 7.2, then k is equal to square root of 7.2 plus or minus. So when I do square root of 7.2, I get 2.68. That means this value is 2.68, this value is minus 2.68. So the zone I'm looking for is the yellow shaded region, because that's when it's actually above, the parabola is above 7.2. So if that's the case, I have two zones. Because I have two zones, I'm going to write and. I'm going to write my two number values, so negative 2.68 and 2.68. So for the right hand side, x is bigger than. For the left hand side, x is smaller than. And that's how I write this answer. So grades, excellence for the final part. If you find the two values, that gets you a merit. And I think for this particular question, just doing this part gets you an achieved. All right, so it's a bit of a mix there. Okay, let's go to question D. Right, with question D, it's you're asked to write this as a single fraction. The most common mistake that I see people do straight away is cross multiply. And when you cross multiply, you end up with a really, really ugly looking equation. And most importantly, the question is actually asking you to write in its simplest form. Okay, so you can't actually cross multiply and end up with a cubic at the denominator. It's just going to be a pain. But what you can do is start looking at factors. So I'm going to factorize x squared minus 9. When I do that, I get x minus 3 and x plus 3 plus 3 times 2x plus 6. I know that 2 is a common factor, and I can take it out, x plus 3. So now it's just a matter of matching up the denominators. So in the left-hand side, I've got x minus 3 and x plus 3. But on the right-hand side, I do not have an x minus 3. So I'm going to add an x minus 3 in the denominator, but I'm also going to add an x minus 3 in the numerator. And again, in the right-hand side, I've got a 2. In this side, I need to put a 2 in the denominator, which means I've also got to multiply 2 in the numerator. So now by doing this, in my numerator on the left-hand side, I've got 2 times 9, which is 18, plus 3 times x on the right-hand side is going to be 3x, and 3 times minus 3, which is minus 9. And the whole thing is now divided by 2x minus 3, x plus 3. Now 18 take away 9 is 9, so you got 3x plus 9 over 2 times x minus 3 and x plus 3. And of course 3 is a common factor in the numerator, so we can take it out again, take out 3 again, and you're left with 2 times x minus 3, x plus 3. And at this point you can see that x plus 3 and x plus 3 is a common factor, cancelling out each other. You end up with 3 divided by 2 times x minus 3. Go. So this particular question gets you a merit. As for achieved, lowest common denominator found, I think I would probably be looking at here, just getting it up to here. For the lowest common denominator found is to get it achieved. Also, one other thing to notice is that in the answer schedule you'll see that x is not equal to 3 or negative 3. The reason they do that is because if they put x equals to 3 here, this fraction is actually invalid. So that's why they actually have that extra little statement. But with you guys, you're not asked to solve or anything like that, so you don't have to worry too much about it. You're just simplifying this fraction as far as you can. All right, let's go to the last question of this paper. So what we have is find the values for m, which has exactly one solution. Okay, so the first step we want to do is we want to get a quadratic out of all of this. And so the way we're going to do it is we're going to write 2mx minus 3. But we know that 8 could be written as 2 to the power of 3. And that's raised to the power of x squared. So what we have is 2mx minus 3 equals 2 to the power of 3x squared. Now because the two bases are the same, we can actually say the two powers must be the same. So we're going to end up with mx minus 3 equals 3x squared. And when we rearrange this, we're going to get 0 equals 3x squared minus mx plus 3. Now we got a quadratic. But we want to know what value for m has exactly one solution. If it's one solution, we know that b squared minus 4ac is equal to 0. So we take our values of a, b, and c. A is equal to 3, b is equal to minus m, c is equal to 3. And substitute the values in. So we've got negative m squared minus 4 times 3, which is a, times 3, which is c. And that's equal to 0. Because b squared minus 4ac equals to 0. So then we've got m squared minus 36 equals to 0. Which means m squared is equal to 36. M is equal to square root of 36, plus or minus of course. So m is equal to plus 6 or minus 6. And guys, nice and easy excellence question right there. Works out really beautifully. Merit up to here gets you a merit, this line here. For achieved, changing basis to 2. Wow, really? Just that part right there gets you an achieved. Okay. Alright guys, so that's basically it for this exam paper. What I will tell you guys is this with the exams for the 2018 paper is just attempt every question that you can. Don't leave anything empty. Don't leave any empty spaces. If you're not sure about an answer, you could always use solver. Which one was I going to show you guys with the solver? I think it was question 2D, sorry. Yeah, actually you can actually do a lot of these questions in the solver as well if you're unsure of how to do certain questions. All right. Yeah, I think I've talked too much there. Guys, good luck for the exams this year. And as usual, if you have any questions or comments or feedback, just write in the comment section below. Of course, don't forget to like, share, and subscribe this video. And thank you for watching.